Welcome to the session on normal distribution. The normal distribution is a special type of continuous distribution. Its PDF is given by f of x is equal to 1 by sigma into root of 2 pi into e raised to negative of x minus mu the whole square divided by 2 sigma square, where x is in between minus infinity and plus infinity. This is the probability density function of normal distribution. Here sigma is greater than 0. Mu and sigma are the parameters. If x follows a normal distribution with parameters mu and sigma, we can write f of x as this, and symbolically we write x follows normal distribution with parameters mu and sigma like this. X follows n mu sigma. We can verify this f of x can define a PDF. The two conditions for a PDF is f of x is greater than or equal to 0 for every values of x, and integral from minus infinity to infinity f of x dx is equal to 1. Here the first condition is satisfied because if we put x in between minus infinity and infinity, this function is always greater than 0 because x is here. This is the exponential function which is always greater than or equal to 0. Now we have to verify the second condition. Integral from minus infinity to infinity f of x dx is equal to integral from minus infinity to infinity f of x is 1 by sigma into root of 2 pi e raised to negative of x minus mu the whole square divided by 2 sigma square. We put x minus mu divided by sigma is equal to some z, then x minus mu equal to sigma into z, which gives dx is equal to sigma into dz. Here mu and sigma are the parameters, both are constants. Therefore dx is equal to sigma into dz. When x here dx, when x is equal to minus infinity, z also equal to minus infinity, z equal to minus infinity, and when x is equal to infinity, z also is equal to infinity. Therefore limits of integration remains the same. This integral will become integral minus infinity to infinity 1 by sigma into root of 2 pi e raised to minus here x minus mu divided by sigma is equal to z, means e raised to minus z square divided by 2. Dx is sigma dz, which is equal to 1 by root of 2 pi, the sigma and sigma cancelled. The remaining terms are 1 by root of 2 pi is a constant that can be taken outside of the integration. 1 by sigma root of 2 pi, 1 by root of 2 pi into integral from minus infinity to infinity e raised to minus z square divided by 2 dz. In order to evaluate this integral, we use a substitution z square by 2 is equal to some t. Note that here this integral here the integrand is e raised to minus z square by 2. Here z square, therefore this is an even function, and so this integral can be written as this is equal to 1 by root 2 pi into 2 times 0 to infinity e raised to minus z square by 2 dz. Now we use the substitution z square by 2 is equal to some t, that is z square is equal to 2t, 2z dz is equal to 2 into dt, that is dz is equal to 2 and 2 cancelled dt by z, that is dt divided by z is from here, z is equal to root of 2t, that is dt divided by root 2 into root t. Root t means t raised to 1 by 2, that is equal to t raised to minus half dt divided by root 2. dz is equal to t raised to minus half dt divided by root 2. If z is equal to 0, then t also is equal to 0, and if z is equal to infinity, t also tends to infinity. Therefore, the limits of integration remains the same. This is equal to 2 divided by root of 2 pi into integral from 0 to infinity e raised to minus t dz is t raised to minus half dt divided by root 2. This root 2 into root 2 is here, which gives 2, and this 2 and 2 cancelled, which is equal to 1 by root pi into integral from 0 to infinity e raised to minus t into t raised to minus half. We write this minus half as t raised to 1 by 2 minus 1 into e raised to minus t dt. This is equal to 1 by root pi into, this is gamma 1 by 2. By the definition of gamma function, gamma n is defined as integral from 0 to infinity x raised to n minus 1 into e raised to minus x dx. This is the definition of gamma function. Here, instead of n, x raised to 1 by 2 minus 1 into e raised to minus t. Here instead of n, here it is 1 by 2. Therefore, this is equal to this integral is gamma 1 by 2, 1 by root pi into gamma 1 by 2, which is equal to 1 by root pi into gamma 1 by 2 is root pi, which is equal to 1. That is integral from minus infinity to infinity f of x dx is equal to 1. That means the second condition for a PDF is satisfied by this function, and hence this f of x is a PDF. Now we have to find the arithmetic mean of the normal distribution. Assume that x is a random variable having the normal distribution with parameters mu and sigma. The arithmetic mean, simply the mean of x is equal to expectation of x, which is equal to, we write expectation of x minus mu plus mu. We just add mu and subtract the same from x. Now we can consider two expectations, that is equal to expectation of x minus mu plus expectation of mu. Here mu is the parameter which is a constant, therefore expectation of this constant mu is mu itself. This is equal to expectation of x minus mu plus mu. That is, we want to find expectation of x minus mu. By definition of expectation, we can write expectation of x minus mu as integral from minus infinity to infinity x minus mu into f of x dx, which is equal to integral from minus infinity to infinity x minus mu into f of x is 1 by sigma into root of 2 pi e raised to negative of x minus mu the whole square divided by 2 sigma square dx. Now we use the substitution as x minus mu divided by sigma is equal to z. Then x minus mu is equal to sigma z, which gives dx is equal to sigma into dz. If x is equal to minus infinity, z also is equal to minus infinity, and if x is equal to infinity, z also is equal to infinity. That means the limits are the same. Therefore, we can write e of x minus mu is equal to integral from minus infinity to infinity. Here x minus mu is equal to sigma z, that is sigma z into 1 by sigma into root of 2 pi e raised to minus, here x minus mu by sigma the whole square means z square divided by 2, dx is sigma dz, which is equal to, here sigma and the sigma cancelled, the remaining are, the sigma is a constant, sigma into sigma divided by root of 2 pi. This is a constant that can be taken outside. Integral from minus infinity to infinity z into e raised to minus z square by 2 dz. Obviously, this function, this integrand is an odd function in Z. Therefore, by the property of the definite integral, this integral will become, because the limits are minus infinity and plus infinity, therefore this integral will become 0. Therefore, E of x minus mu is equal to 0. And so mean of x is equal to 0 plus mu. That means value of this is 0 plus mu. That is mean of x, or expectation of x is the parameter mu itself. Mean of a normal distribution is the parameter mu itself. Now we have to find the variance of the normal distribution. By the definition, variance of x is equal to, the basic definition is expectation of x minus E of x, the whole square. Expectation of x minus E of x, the whole square, that is equal to expectation of, here x minus E of x is mu, x minus mu the whole square. That is variance of x is equal to expectation of x minus mu the whole square, which is equal to, by definition of expectation, it is integral from minus infinity to infinity x minus mu the whole square into f of x dx, which is equal to integral from minus infinity to infinity x minus mu the whole square into f of x is 1 by sigma into root of 2 pi e raised to negative of x minus mu the whole square divided by 2 sigma square dx. We use the substitution x minus mu divided by sigma as z, then x minus mu is equal to sigma into z gives dx is equal to sigma into dz. The limits of integration are the same. Therefore, this is equal to integral from minus infinity to infinity x minus mu the whole square means sigma z the whole square, that is sigma square z square into 1 by sigma into root of 2 pi. Here e raised to minus x minus mu divided by sigma the whole square by 2, that is z square by 2, e raised to minus z square by 2, dx is sigma dz. The sigma and sigma cancelled. The remaining terms are sigma square divided by root 2 pi into integral from minus infinity to infinity z square into e raised to minus z square by 2 dz. Here the integrand is an even function, because here z square, here also square for z. Therefore, this is an even function. The integrand is an even function. We can write this as sigma square by root 2 pi into 2 times integral from 0 to infinity z square e raised to minus z square by 2 dz. Now, in order to integrate or evaluate this integral, we use the substitution as z square by 2 is equal to some t. That means 2z is equal to 2t, or sorry, 2z dz by 2 is equal to dt. That means dz is equal to dt by z, that is dt by, here z square equal to 2t means z is root of 2t, that is t raised to root t means t raised to 1 by 2. If we take into numerator, it is t raised to minus half dt divided by root 2. When z is equal to 0, t equal to 0, and when z is equal to infinity, t also is equal to infinity. That means the limits are the same. Therefore, this is equal to sigma square by root of 2 pi, here root of 2 pi, into 2 times integral from 0 to infinity. Z square is from here z square is 2t into e raised to z square by 2 minus z square by 2 means minus t. Dz is t raised to minus half dt divided by root 2, which is equal to, here root 2 is root 2 into this root 2 means 2, that 2 and 2 cancelled. The remaining terms are sigma square divided by root pi into once again 2, that means 2 into integral from 0 to infinity. Here t raised to 1 into t raised to minus half means t raised to half into e raised to minus t dt. This is equal to 2 sigma square divided by root pi into this is gamma 1 by 2 plus 1. The definition of gamma function is gamma n is equal to integral from 0 to infinity t raised to n minus 1 into e raised to minus t dt. If we replace n with n plus 1, we get gamma n plus 1 as integral from 0 to infinity t raised to n plus 1 minus 1 means t raised to n into e raised to minus t dt. One comparison, here n is equal to 1 by 2. Instead of n, it is 1 by 2. Therefore, this is gamma 1 by 2 plus 1, which is equal to 2 sigma square divided by root pi. This is gamma 3 by 2. Which is equal to 2 sigma square divided by root pi into gamma 3 by 2 can be written as 1 by 2 into gamma 1 by 2. Because we have a recurrence relation, gamma n is equal to n minus 1 into gamma n minus 1. Using this recurrence relation on gamma function, we can write gamma 3 by 2 as 3 by 2 minus 1 into gamma 3 by 2 minus 1 that is 1 by 2. 3 by 2 minus 1 means 1 by 2 into gamma 1 by 2, which is equal to 2 sigma square divided by root pi into 1 by 2 into gamma 1 by 2 is root of pi, which is a standard value. For this 2 and 2 cancelled, root pi and root pi cancelled. That means it is equal to sigma square. That is variance of x is equal to sigma square. That is variance of a normal distribution is the square of its parameter sigma, and therefore the standard deviation is positive square root of variance means positive square root of sigma square, that is sigma itself. Here f of x equal to 1 by sigma into root of 2 pi e raised to minus of x minus mu the whole square divided by sigma square for minus infinity less than x less than infinity. It is the probability density function of the normal distribution. Here x is continuous. Therefore, we can draw the corresponding graph of this function. That graph is known as the probability curve or the normal curve, probability curve or the normal curve. This normal curve is symmetrical about the line x is equal to mu. This is not the y-axis. This is the line x equal to mu. The y-axis is somewhere here or in the right portion. That is the normal curve is symmetrical about the line x equal to mu, and the x-axis is the tangent. It is tangent means the meeting point is at infinity. This is the normal curve. Now let me conclude this session. In this session we discussed the probability density function of the normal distribution, mean of normal distribution, and the variance of normal distribution. Thank you for listening the class. Have a nice day.